Yes, my voice is my photo. Yes. Good afternoon, everyone from Dubai, from the Robotic Surgery Academy, and from Tokyo, Japan, Professor Maki Sogomoto. We welcome you to this important webinar on the virtual surgery. It will deal with the last advance of this technology and its uses, and we are proud to give these information to the souls that have been lost in the COVID crisis in the world, and in Iraq and Japan, and in UAE. We send the gifts for them in protecting the humanity, and for the doctors who were the fighters in the front lines. So you can ask us any question after we finish the three lectures, and of course we will answer any question.
يقدر يصير بيض مسلوق وكورن فليكس بس.
Yes, okay. So Professor Maki, how are you, Professor? How are you, Professor?
Hi, how are you?
Yes.
Hi.
Nice to meet you here.
I'm fine.
Nice to meet all the audience. I will give 15-minute quick lecture about the terminologies and some things regarding to the space telesurgery, and after that I will leave for you to give us your lecture, Professor.
Dr. Ansari?
Yes.
Dr. Ansari, please, could you allow me to record this screen?
Yeah.
Could you give me some permission to record this?
Yeah, please. Make Professor Sogomoto the admin. We will make you the admin, Professor. Yeah. Yes.
Or could you give me the permission to admin?
I will. We'll give you the IT department. Just IT, please. Put him on admin.
Sure.
And please, in the end of the webinar, anyone who is interested to have a certificate, there's an email. He will email us, and of course we will issue the certificate according to the rules of the Robotic Academy and the Teikyo Innovate Lab. We are proud of the cooperation with Professor Maki, and before 2 days, a new history has been written to operate together the first world virtual reality guided telesurgery between Dubai and Tokyo. It was a nice victory, and it was published, and of course you saw it on our social media, and many press are going to make some reports about it. And today we will give some information, some terminology for the surgeons, for the doctors, for the people attending this webinar. They can be either a general surgeon or medical practitioners, radiologists, internal medicine, specialist surgeon in subspecialties, because it is a combination of science and surgery. And of course, even if they have interest in space, because the net result of what we are doing together will be what we will end where. Yes, please. So we will start the lecture. Okay, my PowerPoint. Yes. Second page, please. Yes. Okay. Virtual reality. The first page, please. Yes. What is virtual surgery? Definition. Virtual surgical planning. Which the first page, please. Definition of virtual surgery. The first page. What is the first page? This one. Okay. Virtual surgical planning, or the virtual surgery. It provides both the surgeon and the patient with a wealth of benefits. Virtually, no down waste, an essential tool for the pre-surgical planning. The visual surgery planning provides surgeons with a clear 3D visualization of patient anatomy to develop a surgical plan prior to entering the operative room. The most important advance in the medical practice and in the surgical practice in the previous 10 years is the medical imaging that allows the surgeons and the doctors to take an idea about what they are facing, especially for the OR, for the surgeon before he enters the OR, so that he will see or he will imagine a plan of what's happening. And this is the rule of virtual reality. Yes, please. Next page, please. The augmented reality assisted surgery. What is the description? It is augmented assisted surgery, which is a surgical tool utilizing technology that superimposes a computer generated image on a surgeon's view of the operative field, thus providing a composite view of surgeon and patient with the computer generated overlay, enhancing the operative experience. In such, the information will be given to the surgeon in a virtual reality description in front of the patient. Example, the patient is in the OR and we want to operate the surgery, so we'll see the organs that we want to. Example, if we have a tumor of the pancreas or of the liver, so we will see the anatomical structure of this problems and this medical problems that we are facing, so that we will be ready to the surgery, whether by minimal invasive or by robotic. Okay, and we will have a clear information. Next slide, please. What is surgical navigation? The surgical navigation is a method guiding surgery using medical imaging as a guidance map. The goal of the surgical navigation is to maximize the treatment effect of surgery while minimizing the trauma to the patient by avoiding damage to the critical structure. The most common form of surgical navigation is the image-guided surgical navigation, which is mainly used to perform open surgery in minimal invasive fashion. This is very important to decrease the post-operative complication. And you know all, facing and doing complicated surgery, we want to protect our patient. And believe me, the science and the revolution of science have decreased the post-operative complication, because the surgeon now can see the vital structure and they try to avoid. And with the use of the surgical navigation, it can give us a detailed program before the surgery that the surgeon can enter, and he will see what he is facing, so that he will avoid the vital structures. Examples: the plexus of the prostate in the prostatic surgery, prostatectomy, or the para-aortic plexus in the colon surgery, and many anatomical landmarks in pancreatic surgery and in liver surgery. Next slide, please. An advanced form of surgical navigation used a guide or even both tool to perform operative management and operating position. The most recent form of surgical navigation is ablation and radiation therapy directed by image guidance, which involved by the surgical navigation using the available technology. The technology that make surgical navigation possible include surgical planning, guidance, and tool tracking. All current of surgical navigation is made possible by the progress in computer and sensor technology in the last 2 decades. The future direction of surgical navigation may involve intraoperative imaging as well as simulation treatment effects from the intraoperative imaging. Next slide, please. The virtual surgery intelligence. Okay. The virtual surgery. Yes. One of the important advantages of what we reached today and what we saw in the operative that we did before 2 days, and how we are reaching the telesurgery or the space telesurgery, is what you see in front of me: artificial intelligence, AI. What is artificial intelligence? It is the theory of development of computer systems which are able to perform tasks normally requiring human intelligence, which means it is a mixture of many high technology computer programs in order to achieve a behavior similar to the human intelligence and achieving goals that we cannot achieve depending on the human brain alone. And this is what is the revolution that you are seeing in all what is happening now. The virtual surgery intelligence, it is a mixture of both, which means it uses artificial intelligence to render MRI and CT images in 3D direction. When a surgeon puts an augmented mixed reality headset with a 3D imaging merely virtually with the patient, giving the surgeon a new level of anatomical details. This scan can be controlled with gesture and speech command. It is possible medical imaging in a 3D hologram, which the user can freely manipulate around the physical environment. Those images are automatically fixed onto the body patient. This means doctors can slice through those holograms in order to expose the patient's internal structures without having a look at a specific device or screen. And as you saw, mixing the virtual reality and virtual surgery with artificial intelligence will lead us to a new super act and effect in decreasing the complication rate of surgery and in increasing the quality of success rate of the surgery. By mixing MRI, CT scan, 3D guided imaging, and even telesurgery programs that can be sent to other parts of the world and experience change. Next slide, please. And therefore, it displays medical imaging in a 3D direction hologram, which users can freely manipulate around the physical environment. Those images are automatically fixed onto the body of the patient, as I told you. For example, the patient is in the OR, and we want to do the surgery, and you can see in front of me that this is the liver, and you can, all of you know the complicated anatomical landmarks of the liver, including the vascular supply and the venous and arterial system, and also the 8 lobes. So that the doctor can slice through those holograms in order to explore the patient's internal structures without having to look at any specific devices or screens. So after the surgeon wear his headsets, we will speak about the headsets also later on. The doctor will see the anatomical landmarks, for example, of the tumor. Like let's say we have a tumor in the lobe 8 or lobe 7, and we want to see the anatomical structure and how we can do and remove surgically this lobe with a robot or by minimum invasive method without affecting the other structure. So we can put our headsets on and we can see this anatomical relationship in order to protect our patient. Next slide, please. Mixing these two structures together. Example, this is the liver. He is in the minimum invasive method. Okay, and this is the robotic surgery. Okay, so now we will mix, as I told you, the two imaging together in a live surgery fashion, that we can see our tumor or our pathology in order to display. So either it will be displayed on our headsets when we put it on our head, or it can be mixed and sent to the OR directly when I put my headset and look in the OR field and I want to operate by the robot, like what you are seeing now. And this, we can see the anterior view, the superior view, the inferior view, and of course, to see our structures and to arrange. It is very helpful in liver transplant surgery to choose for the donor right lobe or left lobe, and also in the tumor, like oncology, minimum invasive or robotic oncology. So it can give you a real-time staging process. And as you can see here, when moving the robotic arms, the pathology is inside. If you see by the naked eye, it's difficult. But when mixing with the mixed reality, we can see the shape and recovery feature-based approach and take a 3D figure of what is our pathology. And after that, we will give our decision what to do. Example, right lobectomy, left lobectomy, segment 8 segmentectomy, or segment 5 or 7 accordingly. And see, now this is the mixture that I'm telling you. We will mix the two things together. And even when the patient take a respiration, and you know, when we operate on a live patient, they are moving. So the picture will start to move in order that I will see my pathology and the structure, and I can operate. With the use of the robot and the robot facility and the 3D vision, and with the use of the visual reality and artificial intelligence, the quality of surgery and success rate of the surgery will increase, and the post-operative complication will decrease. So in the future, the surgeon will not, all of us working surgery 20 years back or even 25 years, when we are using our simple tools and we were having our knife and scalpel and simple tools. And so just imagine between these two periods and what is going on, and now this all reflects patient saving life and success rate of surgery. Next slide, please. Next slide one, please. Okay. Now we'll go to the things that I told you. I will give a quick talk about this virtual reality telesurgery, mixing also the information. And as I told you, you can see here on my left side, Dr. Mohammed wearing the headset. It is Oculus special headsets with these two arms. And I'm here in the Emirates Specialty Hospital. And this is my reflection, as you can see in Japan, which is the virtual hologram of Dr. Mohammed. You can see me, the same physical, tall and length. And also, I can see, I can move, I can hear. Okay, it is so I transferred myself physically to other parts of the world 8,000 kilometers away in order to.
رايحين صايرين يلعبون اتاري حتى يسوون العمليه.
Yes. So this is a new revolution of what's going on. Okay. And you can see in the down picture.
اليدات يتحكمون باليدات والآلة هي اللي تسوي العملية.
Now you can see the two professors, Professor Maki and Professor Shiga. Professor Maki, they are also wearing the headsets and the HoloLens in order to make the surgical team, the international surgical team that we are operating now internationally, and sharing experience. So and on the right side, you will see them in the hologram manner. Okay, and believe me, when we did the surgery, it was like I with them. It was a gastric sleeve. One surgeon was operating in the actual surgery, and we were with him. And it was a revolution. Why? Because this is the first time ever in history a surgeon is transferred in his physical act, seeing, hearing, and seeing what's on. So I can operate in Japan, and the Japanese team can operate in Dubai. And this what has been done and published 2 days back. Next slide, please. Okay, so these are the two structures that joined the Robotic Surgery Academy and the Innovation Lab, Teikyo University, Dr. Mohammed and Professor Maki. Next slide, please. Okay, space surgery. Of what we all said, and the revolution of 20 years of work, and the revolution of minimal invasive surgery, robotic surgery, 4G technology, headsets, virtual reality, artificial intelligence. Now we feel proud to offer our services to the International Space Station and Moon and Mars. How? The same headset that you saw and the information and technologies that I can put myself in a hologram fashion and send myself to the International Space Station in order to see and feel and hear the astronauts if they need any medical emergency. Imagine that if they have any acute abdominal pain, you know, they stay there for 6 months or even sometimes 8 months. They are left there alone. Of course, they are protected in the new with the telecommunication, but sending a person to them in this manner, it's very nice. So if they face any problem, they can go to a special rescue program. They will press. In 2 minutes, Dr. Mohammed will be in the International Space Station, seeing them, examining them, and even if they face any emergency or cut or something, can treat them and tell them what to do. We are going now further from that. Next slide, please. The same technology can be launched to Mars. Okay, and as you saw, the Mars mission and Hope mission was launched 3 days back, and it is on its way to Moon and to Mars. And of course, we can send the same structure that you saw to the space, and it's called space telesurgery. In the end of this, I will reach to end of the lecture. I will take your question after Professor Maki will finish his talk. And of course, this is what is meant by space telesurgery. Thank you very much, Dr. Mohammed Al-Ansari. Professor Maki, now we are with you. Yes, make my admin, please.
Thank you very much, Dr. Mohammed Ansari. and then I will have my lecture.
Yes.
I will share my.
Yes.
Could you turn off your sharing, okay? And I will
Yeah.
share my.
Yeah. Share. Stop my sharing. I will. Okay.
Yeah. Hi everyone, my name is Maki Sugimoto, MD, PhD, and I'm a hepatobiliary surgeon and a urologist in Japan, Tokyo, Japan. And then today I would like to talk about the extended reality for telesurgery. And I will show you my slide like this. You see?
Yes, Professor.
Okay, I will have my presentation here. So minimum invasive surgery requires high degrees of spatial awareness and orientation because of complex anatomies and limitation environment. Surgeon's spatial awareness is diminished, as you know. So we have been reported and developed the development of the evaluation of minimum invasive surgery training system using extended reality. This is consists of the virtual reality, augmented reality, and mixed reality. And nowadays, we are focusing on the radiomics. Radiomics means radiology and omics. The processing of radiological imaging data, including the data acquisition and ROI, region of interest segmentation, and feature extraction. So you need to take the organ's shape out from a CAT scan or MRI for surgical planning or surgical simulation. So this is so-called the precision surgery. The precision surgery means that the precision medicine for surgery using the personal data driven radiomics. And now you can see the process of our hollow eyes application here. No, okay. Here. First, you need to data acquisition from a CAT scan or MRI and reconstruct the CD data for surgical planning or surgical navigation. And after detecting the each organ shape from CAT scan data using the manual segmentation or the ROI region interest or extension of same pixel from CAT scan or MRI, and after processing the polygon data of STL5 or OBJ5, you can upload these data to our company's website, HoloEyes JP. After uploading your data to our website, only within 10 minutes, you can download the asset file of each patient data with colors that you like. And after making the automatically building the application of a virtual reality or mixed reality, you can download these asset data to your own head mount display like Windows mixed reality headset or some transparent holographic glasses. So after generating these asset data, you can have experience for extended reality in medicine. And the virtual reality means immersive yourself in a completely artificial world. The augmented reality means underlying the digital data to complex information into a built environment. And the mixed reality means an immersive mix of VR and AR. So using the HoloEyes XR application in the web, you can download this data to your headset and you can see the surgical planning in the head mount display with a monitor to share each surgeons to have some conferences or virtual sessions using these data. And even for several other surgeons, you can use this virtual session application with several head mount display at the same time, and not only with the same room, with the people in the same room, but also the distant part like tele-mentoring. And even it is available for patient-informed consent like this. And student education. And this is the certified medical device only in Japan, and now we are applying to CE mark or FDA in the US. And using this HoloEyes MD, you can see these data in sterile environment during the actual surgery using the transparent head mount display like a HoloLens or a Magic Leap, and for surgical navigation or guiding to your own surgical planning. Or you can mix this data onto a patient body like projection mapping, but this is not a flat projection mapping, but the 3D perceptual projection mapping like a guiding system. So I will share our experience about the virtual reality using the HoloLens XR. And for the experiments for virtual reality, you need the 3 components, 3 elements: presence and interaction and autonomy. And using the Oculus Quest like this, when you wear these glasses, this VR goggle, you can share this data to other people with the movement of the surgeons. And using the transparent head mount display, you can see these virtual reality data in the air like a hologram. This is called mixed reality. So using your gesture like 10 fingers or grab your models by your perceptual inception. And for nurses or for patient family, we can share this data in the air without the monitor or PC or something. It is very useful for understanding each other for perceptual surgical planning or the surgical margin in the patient own data, even during the surgery. And then this is for the guiding system for anesthesia. This anesthesiologist now putting his needle into a back supine. Then he put the needle into a small, the narrow segment of each vertebra, the supine. Is very useful for navigation. And then this is the heart surgery. And now we can open the chest, and you can see transparent bones, esophagus, heart, and around tissues during the data. And this is a pancreatectomy. There is a pancreatic cancer in the pancreatic head. Now you can see the portal vein and a small segmentation of our arteries. Then you can, we could know the surgical margin of this patient, so we can reserve the pancreatic function for this patient. And then for endoscopic surgery, we can put the instrument, the surgical port, onto a patient body, and now you can see the location of each organs. So it is easy to detect the correct area of the surgical insertion of the port. And wearing the goggles, you can see the actual environment through these goggles. Now you can put these ports onto a patient wearing these glasses. And this is the laparoscopic cholecystectomy. Now you can see the biliary tree and the arteries around the gallbladder. And it is very easy to understand the patient individual anatomy and the inflammation situation. And this is the laparoscopic pancreatic duodenectomy. Now you can see the pancreatic head and around the arterial arcade. And this is very useful for teaching purposes for young surgeons. And during surgery, even during surgery, we can detect the cascade data using the hybrid operative system. And this time we put the contrast material into the biliary duct through the cystic duct, and we can reconstruct this biliary tree during surgery. Now, after only 10 minutes, we can reconstruct the biliary tree during the surgery. And within the 30 minutes during surgery, we can reconstruct this data onto a patient abdomen. We can we completed the correct liver resection for biliary tree cancer. And this is not the GI surgeon, but orthopedic surgery. If you when you put the surgical screws to supine, there is a guideline. We can put this guideline onto a patient data, and we can put these needles into a patient back correctly. This guide.
Yes, Professor Maki, we will.
Yes.
I will send you the information of the second session link. Okay, I sent you on WhatsApp the link, the other link. Okay, so we'll continue. Okay, the link I sent you on your WhatsApp the link. Okay.
WhatsApp link. Okay.
Yeah, the link. Okay, so just to put it on in case we lose connection. Okay, because for the other session we have another link, and it will be published also for all audience. Okay, on our Facebook sites. Okay, so, yeah. So it's with you now. Okay, and for others, and so please continue back to your lecture. Thank you for that. Just an information.
So using the virtual session, wearing the goggles, we can share this 3D and 3D perception in the virtual environment between several surgeons. And now you can see the 3D data in the virtual reality environment like this. And it is also available for smartphones. And in Japan, we can buy this kind of a cheap VR goggle, only $1, very cheap. And we can show this 3D data in smartphones. You can share using your own device, bring your own device. And now we are having surgical teaching for young students using the their own smartphone. It is a very cheap system. And this is a spatial. And we can share this 3D data in the spatial location using the spatial I/O application. Now you can use this free on the web, and you can log in this spatial website, and you can log in your own 3D avatar using your on the picture, and we can share the FBX file of the patient like this. And using the HoloLens too, you can share this data in the air using the spatial. So now you can see the avatar behind the actual person like this. This is just real. Using the Azure Kinect, you can send yourself in the point cloud data using the Azure Kinect to Azure server by Microsoft. And you can see the real-time movement and captured movement of the surgeon between the patient. Now we are trying several surgeons all over Japan and in the world. We can share this experience itself. And this week, we having the new experiments with Dr. Ahmed, Dr. Ansari. And this is in our operating room in NTT Medical Center, Tokyo. And he was there like the real person. And we can have the surgical experience even in Tokyo to Dubai, 8,000 kilometers between us. But no time delay, that's the point, no time delay. This is not the 5G, only 4G, okay? After installing the 5G system, we can share this experience more intuitively, right? This is actually the laparoscopic sleeve gastrectomy, but in the near future, we wanted to try the robotic surgery using the telesurgery. You can see that the International Space Station. All right, even for the space, even for Mars, let's go to the Mars. So in conclusion, extraterrestrial surgery improves surgical recognition. They are useful for overcoming limitations of the virtual field and the surgeon's spatial awareness, a minimal invasive surgery. Thank you for attention.
Thank you. Thank you very much, sir. Thank you for all. So we will open we send you our second link in order to receive questions